Assalamualaikum and greetings everyone. Today's topic is on objects motion on a curve. So let's say your object moves on a curve in xyz space given by vector valued function r, where r is equal to xti plus ytj plus ztk. So here t is the parameter. Then you need to know 1, 2, 3, 4, 5 terms. The first term is called the trace or the path. So the trace or the path of a moving object at any time t equals t naught is given by the position vector r at t naught. So if you want to know where your object is on the curve at a given time, so t equals t naught, that is given by the position vector r at t naught. So the end point of your position vector would be the location or the trace or the path of your object on the curve. Next term is velocity vector. So velocity vector is denoted by vt, and it is equal to r prime. And the speed of the object is given by the magnitude of the velocity or the magnitude of r prime. And the direction of the moving object in unit vector would be equal to velocity divided by magnitude of the velocity, and the acceleration vector at t equals t naught is equal to, so here for acceleration we use a, is equal to v prime or r double prime. So when you differentiate velocity vector, you get acceleration vector. Alright, now we have example of that where you're given the curve, you are asked to find velocity and acceleration, or you're given velocity, you are asked to find RT. Okay, so for how are we doing with time? Yeah, we can continue. Okay, let's look at the first example, example A, where you are asked to find velocity and acceleration vectors of an object moving on a path given by, so here we given RT, that would be the curve on the in the xyz space, and we are also are asked to find the speed of the object there as well. Okay, now for vector valued function or the curve. Okay, let me see here, we need more room, I guess. Okay, maybe I can continue here. Right, for example A. Alright, so r is equal to this. Okay, what we want is first velocity. So remember, velocity is equal to r prime. Okay, velocity is equal to r prime. Okay, so we need to differentiate r. So r prime is going to be a vector as well. So you differentiate the x component to get the new x component. So that is just 1. Differentiate t squared, that would be 2t, so that is the y component, and here the z component is t cubed. Differentiate that, we get 3t squared. So that is r prime. Okay, and we are asked to find the velocity at 0.111. so here in the slide here, to get the velocity, we need t naught. So here we need to find what is t naught so that we can find the velocity at t equals t naught. But in our question here, it doesn't give you t naught, but it gives you a point on the curve. So a point on the curve. So this is the x coordinate, y coordinate, and the z coordinate. So what you need to do is you need to find what is the value of t at this point 111. Okay, so you just look at the parametric equation for our curve. So parametric equation for x is t, for y is t squared, and for z is t cubed. So remember, we have the point. So at point 111, so we need to find the value of t. Okay, so x here is 1, the coordinate of y is also 1, and the z coordinate is also 1. So from here you can see that t is equal to 1, because 1 squared also give you 1, 1 cubed is also 1. So at point 111, t is equal to 1. Okay, now we can find the velocity. So remember, velocity is r prime. So velocity at point 1, 1, 1 is equal to v at 1, so or r prime at 1, which is equal to 1i plus 2j plus 3k. Okay, so here I'm using the pointy notation instead of I, j, and k. The next one is we need to find the acceleration. Okay, so for acceleration, let's look at the notes again. For acceleration, is equal to r prime, double prime, sorry. For acceleration, is equal to v prime or r double prime. Okay, so for acceleration, we need to find r double prime or v prime. Okay, so acceleration is equal to a, and this is equal to r double prime. Okay, so what we need to do is we need to differentiate r prime again. So differentiate 1, we get 0. The y component is 2t. Differentiate that, we get a 2. The z component is 3t squared. So differentiate that, we get 6t. Okay, so now we want the acceleration at point 1, 1, 1. So we know at point 1, 1, 1, t is equal to 1. Okay, so a at 1 is equal to, now replacing t with 1, we get 0. Put the x component, the y component is 2, and the z component is 6. So that is acceleration at point t 1, 1, 1, and this is the velocity at point 1, 1, 1. Okay, we are also asked to find the speed of the object there. So the speed is equal to magnitude of the velocity, or the magnitude of r prime. Okay, so this is the velocity. Okay, so the speed is equal to the magnitude of the velocity. So the magnitude of that is equal to, so this is the velocity. So magnitude of that will give us square root of 1 plus, now you need to square the x component, the y component as well. So that's going to be a 4. And the z component, 3 squared is a 9. So from here we get this is equal to square root of 14. So the speed is square root of 14. Okay, so that is example A. Okay, for example B, I'm going to save that for our next video or for our live class. Thank you.